Hi dear students, all of you, welcome back. Today's session, let us continue the Unit 4, Chemical Bonding and Molecular Structure. In that, part 10, bond parameters. Okay? In the previous classes, we discussed about already bond length, bond angle, bond enthalpy and bond order. Okay? So today, we are going to discuss about resonance structure. Okay? What's the meaning of resonance structures? You already know it, Lewis structures. The Lewis structure of some of the molecules will give more than one structures. Just observe this chart. The several number of molecules are there. They give more than two structures. Okay? So, these Lewis structures, the several forms are up there. Those called was canonical forms. Okay? The canonical forms is into hybrid structures. Okay? So this is called what? Resonance structures. Let us know about the definition of resonance structures. Definition: in a resonance structure is a way of describing bonding in a certain molecules or ions by the combination of several contributed structure or called forms is known as canonical forms or resonance structures. Okay? So, these resonance structures or canonical forms into a resonance hybrid or hybrid structures is called resonance structures. Okay, so let us discuss one example, clear definition of resonance structures. And one more thing, single Lewis structures cannot be described in the molecule of structures. Means the single Lewis structures cannot describe the resonance forms. They only the one structures. Okay? So more than one structure of molecules only given a resonant form of structures. Clear? ಒಂದೇ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಇರ್ತಕ್ಕಂಥ ಮಾಲಿಕ್ಯೂಲ್ಗಳು ನಮಗೆ ಕ್ಯಾನಾನಿಕಲ್ ಫಾರ್ಮ್ಸ್ ಅಥವಾ ರೆಸೊನೆನ್ಸ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ಗಳನ್ನು ಕೊಡಲ್ಲ. ಮೋರ್ ದ್ಯಾನ್ ಟೂ ಡಿಫರೆಂಟ್ ಫಾರ್ಮ್ ಆಫ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ನ ಯಾವ ಕೊಡ್ತಾವೋ ಲೀವಿಸ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅಂಥವು ಮಾತ್ರ ರೆಸೊನೆನ್ಸ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ಗಳನ್ನು ಕೊಡ್ತವೆ. ಕ್ಲಿಯರ್? ಸೊ ಲೆಟ್ಸ್ ಟೇಕ್ ಒನ್ ಎಕ್ಸಾಂಪಲ್. ozone, O3 molecules, ozone. Okay, so see here we know about oxygen 3. Okay, so structure already we know it. Structure, the oxygen 3 atoms, so 3 oxygen, One of the oxygen is single bond, another one is double bond. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Octactile. Then 1, 2, 3, 4, 5, 6, 7, 8. Clear? This is one of the structure. Clear? So then this is called what? Resonance structure symbol. This is called representation of resonance structure. This is double headed arrow. This symbol is called double headed arrow. This resonant form of structure symbolically. The two sides having this type of arrow mark. Okay. So it will be the changes. One of the important point is the single bond cannot be, the single bond electrons cannot be involving of resonating forms. Only the pi bonds, more than two, multiple bonds, and a lone pair of electrons only will involve to give resonating forms. Only the transfer of pi and the lone pair of electrons, but not single bond electrons. Okay. These type of double bonds only involving in resonating structures. Clear? So one more point is, say for what? Pi and lone pair of electrons are involved in the resonating forms. Okay. So this is here the changes of one more structure, how they form. Say the double bond of this one is go to here. Okay. So here of oxygen double bond, this is single bond. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and 1. So this is called what? The two structures. What do you say? Resonance structure is a described bonding in a certain molecules, molecule or ions. We will take one more example of ion compound. By the combination of several contributed structures. This is having a two structures. Contributed of two structures. This is called what? Called canonical forms or resonance structure. Canonical forms or resonance structures. Okay. So they give resonance structures. Okay. Into resonance hybrid in the valence bond theory. The theory is involved in the VBT, valence bond theory. So we give these two structures will into hybrid, resonance hybrid structure. How they form of resonance hybrid? This is a symbol of 3 line. Okay. So oxygen. Okay. So here this is a structure we called as resonance hybrid or what we call hybrid structure or hybrid structure. Clear? So oxygen 3 molecule ozone will give 2 canonical forms. Okay? This is called what? Resonance hybrid. Resonance hybrid is only one, but different type of 2, 3 types of canonical forms of molecules are present. The ozone 3 molecule will give 2 types of canonical form structures. Clear? Okay. Just to look at this one. See, oxygen single bond. The bond capacity in the previous class we discussed 148 picometer, right? Okay, what about oxygen and oxygen 121 picometer. Bond length is represent picometers unit. So here same as 121 picometer and this to be 148 picometer. Clear? So in the case of resonance hybrid, this is a single bond, here is a double bond. So double bond in the right side, in the case of two, in the case of second canonical forms, double bond in the left side. Okay. But what about in the resonance hybrid? Resonance hybrid is involving of either right side, either left side of these two molecules is representing a single structure. They have it will belong to the either single bond, either pi bonds. Okay, this oxygen is involving of single bond, either this type, either double bond of this type. Otherwise, these oxygen is look like single bond, either involving of double bond. C is called resonance hybrid. So it having a 128 picometer. So just observe here. So oxygen single bond is 148 picometer. Oxygen double bond is 121 picometer. So in the resonance hybrid they give 128. It means this resonance hybrid, it is involving of the single bond, either double bond between the values. Okay, we write in the experimental calculations, we'll get this type of 128 picometers. Okay, so between the value will come from this resonance hybrid. Clear? In a single bond is 148, the double bond is 121. So decrease. We already discussed in the last videos of last classes. What they said: hydrogen single bond, oxygen double bond, nitrogen triple bond. Right? So bond order increase. 1, 2, 3. Bond order is increases. Bond enthalpy is the breaking of bond. Increases, and bond length decreases. Okay, see here 1, 2, 3 it goes on increases values, bond order increases, bond enthalpy values also increases. Okay, but bond length decreases. See here, single bond the bond length is 148, double bond is increases the bond order, they make decreases in bond length. Okay, this is about bond order, bond enthalpy and bond length. Okay students, clear? Okay, one more example is carbonate ion. We take carbonate ion. It's a symbol. Carbonate ion, CO3 minus 2 carbonate. Okay. So carbon is a central atom. Oxygen 3. 3 oxygen atoms in the corner, triangular corner position. 1, 2, 3. One of the oxygen having the double bond. Remaining 2 are single bonds. Why single bonds? Minus 2 charge is present. Okay. So where it is single bond, it is representing in a minus charge, minus 2. Okay, just write dot Lewis dot structures wise. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is a one form of canonical structure. So one more. It will be, say, the double bond is going to be This is take one oxygen atom, this is two oxygen atom, this is three oxygen atom. Just representation. The first oxygen and carbon atom of double bond is going to only the pi bond changes this position. So it is come from here, second oxygen. So this oxygen carries minus 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, then minus charge 1, 2, 3, 4, 5, 6. Okay, one more type of canonical forms. This is the second one. The oxygen carbon double bond come from third position. Okay, third oxygen place. So this is minus, having minus. Clear? So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay. In the last ozone molecule will give two canonical forms, but in a carbonate ion will give three canonical forms of structures. Okay, so resonance structures. So what about in the resonance hybrid? These are all what? Canonical forms or resonance structures. This is resonance hybrid. Okay. So resonance hybrid structure is oxygen, clear? So okay, this is the resonance hybrid structure of carbonate ion. Okay. So just to see here, in the minus charges, having two minus charge is represented in a canonical form of two single bonded oxygen carbon atoms. Okay. Yelli carbon matte oxygen single bond irutho, aa single bonded irtakanta kade oxygen molecule minus charge bartade, because more electronegative than carbon atom. Carbon kinda oxygen more electronegative irundre minus charge oxygen kade bartade. Okay. So yelli double bond irutade fulfill, hagagi ನಾವು ಅಲ್ಲಿ ಯಾವುದೇ ಚಾರ್ಜ್ ಬರೆಯೋದಿಲ್ಲ. So in the place of hybrid structure, resonance hybrid, so minus charge is would be the in the bracket, because minus two charges in the resonance hybrid we not specify or mention particularly in the oxygen atoms. It is minus two charge overall the atoms of molecule, it is involved. Clear? Then minus 2 in the resonance hybrid alli minus 2 charge ನಾವು particular ಆಗಿ ಯಾವುದೇ ಒಂದು ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಅಲ್ಲಿ ತೋರಿಸಲ್ಲ. ಯಾಕೆ ತೋರಿಸಲ್ಲ ಅಂದ್ರೆ minus 2 ಚಾರ್ಜಸ್ ಎಲ್ಲ ಆಟಮ್ಗಳಿಗೆ ಇನ್ವಾಲ್ವ್ ಆಗಿ ಇರುತ್ತೆ. ಅದನ್ನ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ minus 2 ಅಂತ ತೋರಿಸ್ತೀವಿ. ಓಕೆ, ಬಟ್ ಇನ್ ದ canonical form particular ಎಲ್ಲಿ ಸಿಂಗಲ್ ಬಾಂಡ್ ಇರುತ್ತೆ ಅಲ್ಲಿ minus ಚಾರ್ಜ್ ಅನ್ನು ತೋರಿಸ್ತೀವಿ in a carbonate ions. Okay. So this is giving three canonical forms carbonate ion. Clear? Okay. Take one more example. Say carbon dioxide. Carbon dioxide. Carbon is a central atom. Carbon having valence electron is 4. 1, 2, 3, 4. Oxygen valence electron is 6. It will be the sharing of electrons 1, 2. Say remaining are 3, 4, 5, 6. Okay. One more oxygen, because two oxygen are there. So oxygen 2 were involved with carbon of 2 electrons, so remaining 1, 2, 3, 4, 5, 6. Okay, just know it this giving octet rule or not. Say oxygen 1, 2, 3, 4, 5, 6, 7, 8. Carbon 1, 2, 3, 4, 5, 6, 7, 8. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. This is octet rule. This is a first form of canonical and it will give one more type. Say oxygen 1, 2, 3, 4, 5, 6, 7, 8. Carbon 1, 2, 3, 4, 5, 6, 7, 8. And oxygen 7 plus, this is minus, remaining. Okay, just here in this structure, how they form the lone pair of electrons are pi bond electrons. Okay, so in lone pair of electron, this is transferred here, this to be going to the next of oxygen atom. So in these two atoms are come from in this carbon atom. So this make 1, 2, 3, 4. This is 5, 6. This is losses of electron carries positive charge. Okay. And the carbon atom of these electrons is going to the oxygen atom. So 1, 2, 3, 4, 5, 6, 7, 8. This is excess of electrons. So this is carries negative charge. Clear? This is second type of canonical form. This is one more. This is reversible. So this is to be here. These electrons is going to here. This is a reversible, like the structure is giving oxygen 1, 2 plus 1, 2, 3, 4, 5, 6. Carbon 1, 2. Oxygen 1, 2, 3, 4, 5, 6, 7, 8. 6, 7, 8, it's minus. See three canonical forms. This type of called as resonance structure. Okay, so take one more example. So benzene, the C6H6. Okay, so the structure is C carbon. So skeletal structure. H. Every carbon atom is containing one hydrogen atom. Okay. So and alternative double bonds. This is the structure of benzene. Okay. Canonical forms. It will be write like this also. Okay. So they can write like this. This means having carbon atom. And this represent is a carbon atom and having hydrogen also presence. Okay, we do not mention that. So, canonical form of benzene is so 1, 2, 3, 4, 5, 6. So one type of structure. So second one, same benzene. So in this double bond is right here. Okay. So C is 1, 2, 3, 4, 5, 6. So both two are the canonical forms. So what about resonance hybrid? Will be resonance hybrid. We write like this. Okay, say resonance hybrid of benzene structure. Okay, benzene will give two canonical form of structures. Okay, students, this is about the resonance structures. In the next class, we discuss about the last one, polarity of bonds. Okay, understand? Thank you.